All right, kids, this video is going to talk about sections 9.3 and 9.4. They're closely related. Okay, I'm going to go straight into examples here. So these instructions are going to be simplify. And we've really done some of this before. Well, this first thing is something we've done before. So 2x times 4x plus 1 minus 3x times 5x plus 2. And I'm hoping that all of you guys say, okay, you distribute, and then after you distribute, you combine like terms. Now remember, this would be what? Ax squared, because you have to add these invisible ones on the exponent. This would be minus 15x squared, and then minus 6x. Now you always go in standard form, so you do use the biggest powers. When you combine those, you get negative x squared. 2x minus 6x is negative 4x. If we had to name it, we would say it's a quadratic binomial. But what's going to be different now is, 4x plus 3 times 2x minus 7. Okay? So what we're doing here is we're still distributing. So what you do is you start with this 4x, and you're going to distribute it to the 2x and to the negative 7. We're distributing because back-to-back parentheses means multiplication. 4x times 2x is 8x squared. 4x times negative 7 is negative 28x. But you see, now we're done with the 4x. Okay, so now we scooch over to the 3, and we do the same thing to that. We distribute it to both those things. So we're going to get plus 6x, 3 times 2x, and then minus 21x. And of course, we're going to combine like terms. Now, there's nothing to combine the 8x squared with, so that stays there. Negative 28x and 6x is negative 22x. And then you bring down, sorry, I messed up. This shouldn't have an x on it, right? This would be just minus 21 at the end. There you go. It's just distribution. Okay? Sometimes it'll look a little bit uglier. I'll do, 5x squared minus x times 6x squared minus 3x plus 9x. We'll just say plus 9 here. So we have a binomial times a trinomial. Same process. I'm not going to draw the arrows because it gets a little bit messy. But again, start with the 5x squared. Multiply it by all three of these things. So that's going to be 30x to the fourth, because you're adding those. Minus 15x to the third. And then what? We get plus 45x squared. Scooch over to this and multiply the negative x times all three of those. So we get negative 6x to the third plus 3x squared minus 9x. And again, we got to combine like terms. Nothing to combine with this 30x to the fourth, so I write that first. Done. Now these x to the thirds, I get negative 15 and negative 6. That's negative 21. Now remember, it's still x to the third. Positive 45 and positive 3 is positive 48x squared and minus 9x. And we're done. That would be a quartic polynomial with 4 terms, in case you're wondering. So that's the general idea. You're still just distributing. Okay? I'm going to show a couple other problems here as well. Okay, shaded area problem. This is classic for this section now, because now you have the skills to do something a little bit more interesting. So let's say we have a rectangle within a rectangle. I'm going to call this x. I'm going to call this 3x minus 1. I'm going to call this 5x plus 2. And this will be 4x. Whoops. Need a little bit more room. We'll call this 4x plus 1. And then the shaded area would be this. So you got to think about just what's the process going to be of you to find this shaded area. And I hope you say, well, you find the area of the whole thing, and then you subtract out this little window that you don't need because that's not shaded. And that's exactly what we're going to do. But we're going to be smart about it. We're going to label so that way you can tell what you're doing. So the area of the whole thing, that would be the 4x plus 1 times 5x plus 2. Because remember, area of a rectangle is length times width. And now we just distribute that 4x. 4x times 5x is 20x squared. 4x times 2 is 8x. 1 times 5x. 1 times 2. Combine like terms. Now that's the area of the entire thing. But remember, we're not done because we have to do the area of the window. And that would be x times 3x minus 1, which would equal 3x squared minus x. Now this is where you got to be careful because this is where students get lazy. Now we have to subtract these two things. I'm going to start with the whole thing, which was 20x squared plus 13x plus 2, and I have to subtract this quantity. Those parentheses are necessary. You're subtracting that window. And when you do that, you realize you got to distribute this invisible -1. So nothing, you don't need parentheses here. Nothing changed in the front. But then you -1 times 3x squared minus, oh wait, minus times a minus is a plus, you see? Now we combine like terms and we get 17x squared, 13x, that's going to be 14x plus 2. Okay? Now, that's all in section 9.3. 9.4 is just talks about special cases. And there's 3 special cases. I only really want you to remember one of them. Here, I'll show you. I'm going to show you like y plus 5 quantity squared. There's a special case that goes with this, but you don't need to remember it. You know that squared means what? That means multiply by itself, right? So that's really y plus 5 times y plus 5. So you would just write that and then you would do it. You know, y times y times 5, 5 times y, 5 times 5. And you would combine like terms and you're done. Okay? And then there's something else like this is, you know, I could do 2y minus 7 squared. But again, there's a special case that goes with this one too. I don't think it's worth memorizing. You're better off just, you know that squared means multiply by itself. Just do your distribution. 4y squared minus 14y. That's this times this and this times that. Scooch over to the -7. You get -14y again. And then remember, you get plus 49. Combine like terms. There you go. Now I said there's one special case that I'd like you to remember. Now here, I'll show you. Let's say we had something like this. Y plus 5 times y minus 5. So the two binomials are exactly the same, except one has addition, the other has subtraction. Now watch what happens when I distribute. I get y times y times -5, then I get 5 times y, and 5 times 5. Now, whenever you have this, when you have the same exact thing in both places, but one's a plus and one's a minus, you see these middle things are going to end up canceling out. So you can go straight to that. If you see this in the future, the same exact stuff, but one's plus, one's minus, just square this first term, square this last term, and stick a negative in between. Okay? So watch this. Like if I had 3y plus 7 times 3y minus 7. Again, square, it's the same exact thing. One's plus, one's minus. Square the first thing, 9y squared, square the 7, stick a negative there, and you're done. See, you can do what we did up here, and with all the distribution, it's just not necessary. So that's the only special case thing I like you to remember, because it does save a little bit of time, and you can just square the first. Like here, let me show you one with the fractions. You know, which sometimes freaks people out. And this is why that special case is good to remember. Um, so you see how you have the same exact thing twice? Instead of distributing all this with the fractions get real messy, just square 2/3. Remember, 2/3 squared, you square the top, you square the bottom, you get 4/9 x squared. Same thing, square this, square the top, square the bottom, stick a subtraction in between, you're done. If you do the distribution, it'll still work out, but I'm just trying to save you some time. Okay?